Welcome back to the Village Clockmaker. I'm James. In the last video, one of the comments was what's a fusee and what's it used for? And this is what we're making right now. This is a fusee for an English skeleton clock. So here's an English skeleton clock that I'm making. I've got all these gears cut and everything. And this goes in here like that, and the spring is in the barrel. This is the barrel, and let me take this apart and do it right. I'll be right back. Okay, this is the fusee, this is the barrel. The spring that drives the whole clock is in the barrel. And what goes between this and this is one of two things. If this groove here is round on the bottom, then this fusee takes a gut. Let me see if I have some gut. This is gut. It's called cat gut, but I don't think it really is. It's quite stiff and very, very strong. Okay, if this groove is square in the bottom, it takes a chain, and this is a piece of chain. I see. I guess you can see that fairly well. Believe it or not, this is all handmade, probably in India, but this chain is still available in England from Meadows and Passmore, one of the English suppliers. But it's hard to work with, and it's hard to believe that somebody is still making all those little links in there by hand. So that's what a fusee is. This goes in here, and then the chain runs from there to there. And the purpose of it is, in the early days, steel that they used in their springs was not good at all. Some of the springs were handmade, and when the clock was wound completely up, the clock would run fast, and when it was completely wound down, it would run slow. And so this fusee is to counteract that. The chain or gut goes in this groove, and when the clock is fully wound, the gut is here. So you've got a very short lever from the center of that to out here. Then you've got a lot of torque in the spring. And then as the spring gets weaker, this turns like this, and you're increasing the lever arm until you get out to here. And now the spring is very weak, and you've got a much longer lever arm to drive the clock. And of course we don't use fusees anymore, but in the 1700s, early 1800s, they used them a lot, and it was used in watches and clocks. So I hope that explains it all. That's what a fusee is. We'll follow this clock too as we make it. This is one out of John Wilding's book, How to Make an English Skeleton Clock. So now we have our piece of brass ready to go. I've got this faced and cut to length, this length, and we've got our arbor. This is 5/16. It goes through here. So the next thing we have to do is put this back in the 3-jaw chuck and center drill it, and drill a hole 64th under 5/16, and then we'll I can't think of the word, broach it. Phooey. I'll cut that part out. And then we'll ream this to exactly this. Prior to starting this, you see I've knurled the arbor here, and when this is press fit in there, driven in, that will help hold it and keep it from turning. Plus, we'll use some thread locker, some Loctite thread locker on it. This is 222 thread locker, and it works very, very well. Okay, so we'll go over the lathe and start working on this piece. Let's see where, here's my tonker. And make sure that's seated in there real well. Okay. Helps if you turn it on. Good. I've got the camera with a magnetic block sitting on the tailstock, and that's not working out very well because every time I move the tailstock, that moves. So let me find a different place for it. All right, just to get the right size hole here, we're looking at the chart. And 5/16 is 0.3125, so we're going to use an N drill, which is 0.3020, and our starter drill is going to be a K, which is 0.2811, which is what we have in there now. So we'll use this smaller drill to start, and then we'll switch to the N, and then we'll ream it with a 5/16 reamer. I don't use any liquid love on brass. you could. Lard is really good, but you don't really need it. If this was anything else, even aluminum, we'd be using some liquid on it. Today is February 17th, and it is 42 degrees outside the shop. Monday, what's today is Wednesday. Yeah, today's Wednesday. Monday, it was 7 below zero. The weather's been really crazy in Maine, probably other places too, but it's been really nuts here. So we're expecting spring any minute. Almost there. Yeah, we're through. Even though we're being careful, that's the K. This is the K. This is the N, which is just a few thousandths under 5/16. That drill is. Not necessarily. Okay. Get our arbor here and see how close we are. And always remember to keep my hands out of there. Okay, that's not a press fit yet. So we're just right on the money. So let me find a 5/16 reamer and we'll be right back. We found a 5/16 reamer, so we're ready to ream this out. perfect. That's just a nice press fit. When we get up to here, that's going to be good and solid with some Loctite on it. So I guess we'll stop now. I'll drive that in the press and put the Loctite on it, and we'll let it set overnight. And then we'll come back tomorrow when we're ready to turn this is turned to length now, but it's not turned to diameter. So tomorrow morning we'll turn that down to diameter. The reason we put the arbor in first, of course, is that now this will be absolutely perfect and true once we get it turned down to the right diameter. I pressed the arbor here into the stock last night, and with that knurl on there, I did it in the 12-ton press. It was really a tight fit, which is exactly what you want. You don't want that to come out there ever, and you don't want to spin on the shaft. So we're going to take this now down to the proper diameter. So what we're after here is 47 up. This vernier keeps changing itself back to millimeters, and I don't work much in millimeters, so we're 1.857. We got quite a ways to go. 1.917. We're close. This is 1.857, and right now we're 1.867, so we got 10 more. So we'll take a spring cut on this. And that should do it. Zero the DRO. .856, close enough. .856, 1.853, 0.83. Excellent. Okay, now we're going to take this off, put our tooling that we built on, and we'll start putting the arc in.